Hi, I'm Rich with insideHPC. We're here at ISC 14 in Leipzig, Germany at the Intel booth, and I'm here with Eric Barton. Eric, how are you doing?
I'm pretty good, thanks.
You're pretty good? Oh, good, good. Well, I wanted to congratulate you. I know with the FastForward project you have been working on, it's just about to wrap up. Can you remind me again, what was this about?
Well, it was really about addressing the problems that the Posix I/O stack is going to give at Exascale. It's the massive concurrency that we expect and the scale of the hardware and therefore the fault tolerance requirement. Posix just can't handle it. You're forced in the direction of huge namespaces with millions of files that become completely unmanageable. And Posix provides no way of encapsulating, the entire data sets that will be worked on at Exascale, including huge amounts of complex metadata, in ways that Posix can manage. Posix today only allows you to create new files. If you try to overwrite or update existing databases, if anything goes wrong in the middle of it, you're going to corrupt your data. At the scale of data that we expect at Exascale, that's going to make the whole thing completely unmanageable. So we had to replace Posix, and that's what we did.
Okay. And so did you create a prototype of how you would work something like a replacement, or what does it look like?
Yeah, we've created a prototype. It's a layered stack. At the bottom of the stack is an object storage API. That really is replacing Posix. It's transactional. You can do asynchronous operations on it, so it will scale much better to the millions of processes you expect at Exascale. And it provides consistency guarantees that upper layers can then use to safeguard the data through integrity checks and redundancy schemes. The top of the stack, we want to get away from byte stream oriented I/O and give programmers an object database basically to play with, so they can represent their data structures directly in the storage rather than having to go through conventional stacks. In the middle is a layer that kind of does the impedance match between the two. The top level has very varied requirements for different types of I/O. For instance, you could imagine a single array that's composed of petabytes of data or billions of tiny objects. It's a huge dynamic range that you have to cope with. Underneath it, you've got the storage, and the storage, some storage might be good for small, tiny I/O, other storage might be really good for streaming. And the middle layer manages the tiering, the storage tiering, burst buffers, and matches the application I/O requirement to the underlying hardware.
So how does FastForward work? They get the output of this. What do you think is the next steps on their side?
Well, we really would like to take the prototype forward and start testing it at far greater scale. Working on stability, working on performance, addressing some of the things that we just didn't have time to. We had partners in the project. EMC implemented the middle burst buffer layer. The HDF group implemented the top layer. We implemented the bottom layer with help from DDN. And all of us are really raring to go and take this forward.